Okay, I'm still experimenting with this recording, but I wanted to show you where I calculated the number of classes. To get these numbers that I have gotten, you have to use the 2 to the k power. 2 to what power is greater than or equal to these numbers? Well, if you try 2 to the 6th, it's 64, which would not be bigger than 100. So you have to go up to 7, which is 128, which is greater than 100. So your class size, you would have 7 classes. For 250, you would have to go up to 2 to the 8th power for it to be greater than 250. And also 2 to the 10th power would be greater than or equal to 750, and 2 to the 12th power would be greater than or equal to 2500. So for a sample data of 100 numbers or points, you would need at least 7 classes. So you would use a total of 7 classes. So you always use, it's always 2 to the k power, and you want k to result in a number that is greater than or equal to the numbers that you have. Moving on. Okay. Also, it says I have listed the values of numbers for discrete. Discrete means that it cuts off from one point to the next. It does not continue. And like I said, we determined if we have 38 numbers, our class size, the number of classes we would need would be 6, because 2 to the 6th power is 32. So I have chosen 1, 2, 3, 4, 5, 6 class sizes, answer choice D. Now, how did I calculate how many numbers are in each class? You take the maximum value, subtract the minimum value, and then you divide by your number of classes, which was the 2k rule we determined to be 6. So if you do 71 minus 12 divided by 6, you will get a decimal 9. That's a little bit over 9, but you always round up to the next number no matter what. So the class width is 10. So if you calculated 12 to 21, that is actually 10 numbers, because you are including both 12 and 21 in that calculation. Then when you go up to the next class size, you start with the next number, 22 to 31, 32 to 41, 42 to 51, and so forth. Okay, and then the difference between, this is the one that I had started working, but I wanted to show you something. It's just like discrete. You want the numbers to include 12 to 21, but it doesn't say 12 to 21. It says 12 to less than 22. And you're going to pick up with that number. 12 to less than 22 would mean the next class would be 22 to less than 32, which would be 22 to 31. And then the next class would be 32, let's look back up here, to 41. So we need to correct this. This should say 32 to less than. If we want to include 41, we have to make that 42. Then the next class would be 42 to less than 52. Do you see the patterns? They're going up by 10 on each side. Okay, and then so the next one should also be a 2, right? 62 to less than 72. And we will check it. Okay. Okay, as far as frequency, you are counting the numbers that you have of each data value. So if you see the number 1, if you count the frequency, how many ones do you have? 1, 2, 3, 4. So you type in 4. And then your 2's, you have 1, 2, 3, 4, 5 2's. And then for 3's, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 threes. And then fours, you have 1, 2 fours, not a lot of fours. And then for 5, you have 1, 2, 3 5s. Now let's make sure that I counted everything. 1, 2, 3, 4, 5, 6. You should have 6 times 4, 24 numbers. If you add these together, 9, 18, 20, 23. Looks like I missed one. Let's check our ones again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's the number that I missed. There are 5 ones. 5 and 5 is 10, 19, 21, 24. Now we have 24 numbers. Okay, that's how you calculate frequency. To calculate relative frequency, you will take your number, the number 5, and divide it by the total number of values you have. So 5 divided by 24, you're going to round to the nearest thousandth, so that would be 0.208. And then look at your next one, which is 5, which is easy. It will be the same. And then look at your 3. You will do 9 divided by 24, which is 0.375. And then you would do 2 divided by 24, which is 0.083. And then the last one is 3 divided by 24, which is 0.125. Now notice, these should add up to be 1. If they don't add up to be 1, then you know you've made a mistake. Okay, now for the last part is the cumulative relative frequency. So notice the word cumulative, that means it accumulates. So we start with our first relative frequency and we just keep adding as we go. So for number 1, the data value 1 is going to be the same, 0.208. Okay, and then you're going to add 0.208 to it, so that would be 0.416, and then you're going to add 0.375 to 0.416, which is, bear with me, I'm doing these calculations as I go, 0.791, and then 0.791 plus 0.083 would be 0.874. Okay, so we have 0.208, 0.416, 0.791, and 0.874, and this would be 0.999, which is 1. So sometimes you will, because of rounding, you won't get exactly 1, but if you don't get close to 1, if you don't get 0.999, then you know you need to go back and recheck. Okay, so what if you have a lot of data and you don't want to calculate the frequency? There is a way in this MyStatLab to go to StatCrunch, and it will help you calculate when you have a lot of numbers. So here we have 1, 2, 3, 4, 5, 6, 12, 18, 24. We have 30 numbers, which means that our class size would have to be 2 to the 5th, which is 32. So we need 5 classes, 1, 2, 3, 4, 5. So the answer would have to be B. Now, how can we calculate this without having to count your numbers? Well, first we need to find the minimum value and the maximum value and divide it by 5. So our minimum value looks to be 13.9, so I will write that number down. And our maximum value looks to be 42.7. So I will write that number down. So I want to do 42.7 minus 13.9 divided by 5. And I get 5.76, which means our class width is 6. And if you look at this, 13 to less than 19, they are using class width of 13, 14, 15, 16, 17, 18 of 6. So you really didn't have to calculate your class width because you could count here up to 18, it doesn't include 19, and get your class width, okay? So how do we do this in StatCrunch? It's very easy and very efficient, but you also need to understand how we got these numbers. That's why I showed you the previous example. So let's open it in StatCrunch. In StatCrunch, I believe, and if you forget, you can always kind of play around, but a histogram is a great way. Always select variable 1. Start at, I believe our table started at 13, and our width is 6, and we want it to tell us the frequency. So let's hit compute and see what happens. If you will click on the number, the frequency of the first class is 6, the frequency of the second class is 11, the frequency of the third class is 4, the frequency of the fourth class is 7, and the frequency of the fifth class is 2. So we can close this out and we can put in our numbers that we got from the histogram. And it saves you a lot of time. It's just learning to use StatCrunch. It's a very helpful tool to save you time on the homework. So let's check it and make sure that our histogram was correct, and it was. Okay, now relative frequency and cumulative relative frequency, I've showed you how to do. You can do those the same way, but this will help you understand how the histogram will help you count the frequency instead of having to do that by hand. And in the next video, I will show you how to get those numbers from StatCrunch also.